Today's lesson will be comparing exponentials and logarithms, both by their graph, their starting XY chart, and then their characteristics, domain, range, interval of increase or decrease, their end behavior, and their asymptotes. So we'll start off with exponentials. Remember, exponentials are in the form y equals something to the x. The graphs for these will typically, I'm just going to draw one. You will have usually an asymptote, not usually, always. You will always have an asymptote. And then you will have a function that will approach the asymptote on one side and then go to either positive or negative infinity. So it could be on the top like this. It could be on the bottom like this. It could be coming down like this. Or it could be like this. So there's basically four different ways that it could go. But one side will always approach the asymptote. The other side will either approach positive or negative infinity. Now for logs, the difference is that my asymptote, instead of going left to right, is going to go up and down. So let's say my asymptote is over here. Then my graph will either look like this, where again, one is approaching the asymptote. The other will approach, again, either positive or negative infinity, depending on whether it is increasing or decreasing. So it could look like this purple graph. It also could look like this blue one right here, where we go from the bottom to the top. But again, one side is always approaching the asymptote. All right, our starting XY charts. Let's see. I'm going to zoom in a little bit for this one. So this is our exponentials. So for exponentials, we will always use 0, 1, because anything to the 0 power is 1, and that's where we'll start off. And then we will also use 1 because anything to the first power is itself. So in this case, our y value would be the base of our exponential. So if it was 4 to the x, our y value would be 4. If it was 12 to the x, our y value would be 12. Now for logs, since these are the inverse, we are switching our x and y's. We're going to mirror this. So now instead of x being 0, x is going to be 1 and y is going to be 0. And then our next coordinate, the x will be our base value and y will be 1. So this is where we would start. And then if we had any transformations, any left or right, any up or downs, any stretch, any flips, any compressions, all of that would happen after this point. This is where we would start. And then we would, for left or right, we would change the x value. For up and down, stretch, compress, flip, that would all change the y value. All right, for asymptotes for an exponential, we are going to have a horizontal asymptote that goes left to right, or left and right. And that will be in the form y equals something. So it could be y equals 5. And that would be from, let's say we had y equals 3 to the x plus 4, and then plus 5. So that would be our asymptote, is whatever's on the very, very end. Now for a log, we're going to have a vertical asymptote. It's going to go up and down. So that would be something like x equals, because remember we've flipped our x's and y's, x equals, let's say, -3, and that would come from, let's say, the equation y equals log base 2 of x plus, whoops, that should be green, plus 3, and then let's say plus 4 on the end. We know that the plus 3 is going to be our vertical asymptote, because our standard asymptote would be x equals 0, and that plus 3 tells us to move it 3 places to the left over to -3. All right, domain. This one's usually nice and easy because a domain of an exponential function is all real numbers, and that is always the case for an exponential function. Now, we know that logs and exponentials are inverses of each other, which means we're switching x and y. Well, my domain is usually my x values, so then my range is my y. So if I am switching those, then now my domain for my exponential is going to become my range for my logs. They're basically going to switch. Now my range, we're going to use our horizontal asymptote, and it will be from my horizontal asymptote to infinity, or -infinity to my horizontal asymptote. We're going to switch these. What was the range for my exponential is going to be the domain for my log. However, with my logs, they will always, always, always go to the right of my vertical asymptote. So we always will have the form vertical asymptote to infinity. We're not going to deal with the left. So it's going to be, this is going to use my vertical asymptote. All right, intervals of increase or decrease. Okay, the nice thing here is that it is the same as my domain, because these are, let's see, these are going to stay the same, or like stay together. My domain and my intervals of increase or decrease, my range and my end behavior will deal with the same values. So let's look at our intervals. Okay, it will either increase or decrease, never both. It's going to be one or the other. But that interval of increase or decrease will always be from -infinity to +infinity, the same as my domain. So because of that, my end behavior is going to be, I'm going to go ahead and finish out the exponentials here. My end behavior, as x goes to -infinity, like it says right here, as x goes to -infinity, y goes somewhere. And as x goes to +infinity, which was this one right here, y goes somewhere. Now, these will always be my horizontal asymptote and either positive or negative infinity. One will be the horizontal asymptote, one will always be positive or negative infinity, depending on whether it is increasing or decreasing. For my logs, the same rule will apply. It will either increase or decrease, but never both. The difference is that my domain for my for my log is from the vertical asymptote to infinity. So that will always be my interval of increase or decrease from the vertical asymptote to positive infinity. And what changes here is that my end behavior, x, is going to approach my vertical asymptote on one side. On the other side, it will approach infinity, positive infinity. My y values will always approach positive or negative infinity. And these will be opposite. One will go to positive, one will go to negative. One is positive, one is negative. And that's it.